Today let's look at the LeetCode problem 110, balanced binary tree. Given a binary tree, determine if it is height balanced. Okay, so when we tell height balanced, what does it mean? A height balanced binary tree is a binary tree in which the depth of two subtrees of every node never differ by more than 1. So basically, when we take any node, the left and right subtrees depth should not be at all levels, should not be greater than 1. Maybe I can just explain this here. So how I see it is, depth is actually defined by the number of edges from a node to the leaf nodes. Now let's come to this node, right? So 9. Then for these both, there is no edges. So that means this is 0. So you will have 0 edges to its left and 0 edges to its right. Okay. Now that means, but when we take from 3, that will be 1 outgoing edge, because it is 1 plus the max depth at 9. Okay. So that means you will have from 3, its left depth is 1. I hope this is clear, because you can see one edge coming from 3 to 9. Now if you take the right side, let's come to 20. From 20 it can come to 15. So that means 15 is a leaf node, so it will have 0 as its depth. Okay, but there is one edge come from 20 to 15, so that means this is the depth at this level. Okay, similarly to 7, this will be 1. Now if you see 2 will have a depth of, 20, my bad. 20 will have a max depth of 1, and 3 has one edge coming towards 20. So that means its right depth will be 2. The difference is 2 minus 1, left and right subtrees. So this is 1. So this is a balanced tree. Okay. Now let's take the case of let's take another example. When we come here, 4 will have 0 because these are leaf nodes. These 4 also will have 0. So 3 will have 1, 1 as its depth. So its depth will be 1. So from 2, so this will be, as you can see, this will become 2 because it has one edge coming from here and this has another edge, and to its right it will be 1. So now that means 2 will have a max of 2 comma 1 plus 1, that is 3. So 3. Okay, because one edge comes from here and the max depth is 2. So it will have 3. So now if you see 3 minus 1 is 2. So that means it's greater than 1. So it's not a balanced tree. I will use a helper also. Helper, and I'll just pass root comma is balanced. Okay, so is balanced, let it be true to start with. So you can also keep track of the max height here, but I prefer to use it this way. You can then just return the is balance. Now let's, because the critical function is the is balance helper, so let's go into that one. If root equal to null ptr, then our since it is not having any edges, we will return -1. Okay. Then my int depth is equal to 1 plus left and is balance. Okay, and then my right depth will be 1 plus will be right. Okay, now ABS L depth minus R depth greater than or equal to, greater than 1, then we can set is balance equal to false. At any level, if it is different, we can just set it that way. we'll pass the max of L depth comma R depth as the output, so that it can be used for higher calculating the depth at the higher levels. Now let's see. Okay, looks good. Okay, so that looks good. And the time complexity will be order of n, and the space complexity will be the height of the tree. Thank you. Have a good one.